Okay, so as this part of the slide says, I'm a bit of a geek and this is home automation. Well, it's sort of IoT-ish. We had IoT before IoT actually had a name, so we know what we're doing. So, before we start, I should say it's home automation and I should clarify what I mean by home automation. So here we have a nice little pithy phrase. If you care to tweet anything, this is the pithy phrase you should be tweeting. Home automation? Yeah, I know. Home automation is anything your home does for you automatically to make living there more enjoyable or productive. It covers many areas like remote and time control of lights, electrical home appliances, distributed media services and communication. All it means is our house can do stuff for us. Basically, my house is now a peripheral of my computer. This is a basic HA system. This is the one that I have at home. It's very, very simple. But on the left, you have input conduits. Messages can come from SMS, from email, or even from a control process itself. That goes into node 0. That's just basically a Linux box. It's running Apache, a few other things, and it does the brains. It does loads of thinking, and it says, oh, I've been requested to do this. And it then goes away and talks to the output conduits on the other side, saying, go away and do this. So, for example, I can send a text message into the computer will then switch the light on, and it will send that message out, say, to Twitter to say, Steve has switched the light on via a text message. It's simple. You know, this is the stuff, this, for what it's worth, of what I use, or one of the things that I use. So, that unit on the left goes to the computer via a USB thing at the top. That puts a message onto the power line. These two units pick up that message from the power lines and then switches either the light or the appliance on. So you can plug a kettle into this, for example. You send a text message when you get to the train station. It then times how long it takes to walk from the train station to home. Subtract the amount of time it takes the kettle to boil. So as soon as you walk in, the kettle is ready. All very simple. But again, we've got input conduits. So actually we could say, well, instead of sending a text message, I know what train Steve's going to be on because his Twitter account went dead when he left the office. Therefore, I know what train he's going to be on. I go to live departure boards, I look at live departure boards, it tells me the train is coming in 5 minutes, and it then does the same calculation, working out how long it takes to get home, and subtracting the time for the kettle to boil. It's all very simple stuff. It's 1,001 very small pieces of code. This one, for example, is probably about 10 years old now, which, if I send an email, I can switch a light on and off. It's not overly exciting or interesting. Basically, all you do is you send emails to yourself saying, light goes on, light goes off. And you repeat that all day, because it's great fun. The control script, you know, there's got to be some Perl in it somewhere, otherwise it wouldn't be allowed here. It's very simple. There's a nice little control module. You send the signal, AJ happens to be the name of the light switch, and it switches it on. Very, very simple code. Or you've got to put the serial port in there, that's the first thing. So if you're running under Linux, as I am, the serial port is going to be a different name to running under Windows. So if you're doing a general system, you've got to change that. How do you know if the user's allowed to? If I send an email to that account, it's got to check that I'm allowed to send emails to that account, and it's got to check that I'm allowed to turn that particular light on and off, or the kettle. And what if I'm using non-X10 devices such as these things? I have to go back and I have to rewrite the code. So far, nothing overly complex. It's not straightforward, but it's just software. It's easily hackable software. But what about in this case? Consider the human timeline. This is the important part here. Human switches the light on. The computer, for whatever reason, says, oh, I should now switch the light on. The computer then, for a similar reason, says, I should now switch the light off. Should that light now be on or off? Well, if the light in question happens to be the bedroom light, and I switch the light on because I'm just going in there to find a book or whatever, then the light should be off when the machine says to turn it off, because I would have left and forgot to turn it off. So the correct answer is the light should be off. Unfortunately, if I'm going into the bedroom because I fancy an early night, therefore I have switched the light on explicitly to read my book, therefore the light should not be switched off when the computer thinks it's time to switch it off. So the correct answer is the light should be on. This is where it starts to get slightly complicated. Because depending on what room in the house is being turned on or off, depends whether the light should be turned on or off, and depends what you are doing in the room that determines whether the light should be on or off. And that's a very simple problem. Media playback. This is one of the things that most people in automation will do. It's one of the first things you do. It's one of the easiest things to do. I have a Raspberry Pi under the bed that does my alarm clock and does music. It's a very simple setup, really. You know, a Raspberry Pi amplifier network cable. At the beginning of the day, it goes away, it gets the train times, it gets the weather report, it wakes me up, it tells me what the weather report is, it tells me my calendar because it downloads it from Google Calendar. It uses eSpeech and also Festival to do a speech synthesizer thingy, so it reads out my calendar for the day, and it plays some music afterwards. I also have a waterproof speaker in the shower to do exactly the same thing. It's quite fun. You come home at night, you switch the shower light on, it realises you've switched the light on, it realises it's 10 o'clock at night, it says, the calendar for tomorrow is this, and it tells you what your calendar is for the following day. If you switch the light on at 1 o'clock, it says, you've obviously had a heavy night, I'm not going to bother telling you what's on tomorrow because you won't remember. Obviously, I've had to program every single bit of that, and it probably won't be applicable for everyone. If you happen to be working nights or on shifts, then that particular set of parameters would mean nothing, and you'd have to go back and reprogram it. But that's someone else's problem. Let's just think about playing music. A common thing people say is, oh yeah, if the doorbell rings, you can automatically reduce the volume of the music that's playing. You know, or it can mute the telly, some people have got. All very easy, all very doable. So, let's look at the code to change the volume. We have one call that gets the volume from somewhere. We change it in some way. Maybe we add a number to it, or we multiply it by a percentage, and then we set the volume back to the mixer. Okay, so imagine we take the volume from the mixer itself. Because it's the mixer, it will cap itself between 0 and 100. So the volume, plus the volume up, plus the volume down again, will not equal the original volume if it ever exceeds the top or goes below the bottom. If you're doing it manually, with a little remote control, it doesn't matter. You keep your finger on the up button until it's loud enough, or you keep your finger on the down button until it's quiet enough. If the computer's doing this for you, it doesn't know how loud or quiet you want it to go, and it doesn't know if you exceed the bounds. So, what we'll do instead is we'll write our own value for the volume out into our own little 10 file in var log somewhere. So, volume up, up, up will equal volume down, 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 regardless of how many times you do it, which solves the first problem. Up will always equal down, except if you keep your finger going up and up and up, you'll hit the down button because it's too loud and it won't do anything, because the volume is currently at 200 and you've got to wait for it to get to 100 for it to have effect. So either way of reading the volume is wrong and will break in some case. Is volume linear? If you increase the volume by just 1 point at some point in the scale, is that the same point at all scale? No, audio is a logarithmic scale. So you end up with code a little more similar to this, which of course has problems when you start going over the bounds. Because you'll say, oh, I'm at 95, I'll decrease or increase by 1, at which point you're in the next bracket which says I now increase or decrease by 2. So up and down are no longer equivalent, because volume up does not equal volume down. It's all coming back to context. If I'm turning something down, why am I turning the volume down? Is it because that song was just mastered at the wrong level and is a bit loud? Am I turning it down because I think there's someone outside and I want to listen more closely to that? It's all about the context, and you just can't tell the context from the simple action of this needs to be a bit quieter. You'd end up with a row of buttons, which was basically for them, say, this track is too loud compared to the last. This has got a loud bit in the middle, I don't want the rock bit of Bohemian Rhapsody to be that loud, thank you. And you have to have separate buttons to explain exactly what you mean by turn the volume down a bit. Same for turning it up, same problem in reverse. So you end up, I'll leave that on there for another second, so you end up having more controls to try and match what you do in your life, which means I can't write any home automation systems for you, and if you want to download or buy them, they're probably not going to work for you either. But that's an easy problem as well. You just keep your finger on the volume up and down until it's right, so there's no automation left. So which user? This is the Node 0 Linux server is running most of these services as the Minerva user. That's the name of the system that I decided to give it. Therefore, every command is run as the Minerva user. That's reasonable. It has access to the mixer device and to the controls and everything else that it needs to control the house. This also means that if kids are sort of watching the telly, the internet-controlled telly, which is just basically this TV box, if they're able to log onto the Linux box, they can see the logs of what they're doing. But you don't really want them looking at the logs. Logging is a fine idea, but you don't want the logs accessible. Because if the kids are watching a film called Toy Story, which has characters like Buzz and Woody, you don't want the kids being able to see the log, where the grown-ups have the more adult version of Toy Story, which also has characters called Buzz and Woody. Yes, I can clear that slide solely for that joke. Make the most of it. So, another easy problem. We want to pick a random song. Almost every music device has got a shuffle play. So we'll have one as well. Very easy to create a piece of code that will pick a random song. Well, here's three possible ways. Your music is ordered in directories. Music directory underneath that, A, B, C, D, E, and so on. Underneath that, Q, green, green slash, quiet, quiet, and so on. So, we'll pick a random directory. If there's another subdirectory, we'll pick one of those random ones and go into that until we just find a list of files and we'll play one of those randomly. Perfect way of getting a random song. But we could also say, well, if there's files and directories in the same directory, then we'll randomly pick either a file or a directory and select one of those. Or we could say, put all the songs together in one list, pick a random number between 1 and 10,000 and play that one. Every single case does not work. And it will not work for a different reason. If I say go into a random directory, then a random directory and so on, if I happen to have something like Zucchero on there, the Italian equivalent of, well, easy listening stuff, but you know, someone likes it, that's going to come up about 1 in 26th of the time. We don't listen to that 1 every 26 times, so that's obviously not going to work. If there are songs and directories, it's not going to work for the same sort of reason. It also means that the files in the directory are going to have less chance of getting picked than it will to iterate recurse into the subdirectories. Plan C. Let's put all the songs in one list and pick a random number. I'm a fan of Queen, as you probably noticed, because I've used it several times. It also has a letter Q, which makes it a slightly more esoteric letter. But I've probably got about 30 or 40 Queen albums on there, which means about after 10,000 songs, probably 5,000 are by Queen. Therefore, every other song is going to play Queen, and this solution doesn't work. So in actuality, none of those answers work, so you do some random variation of it. You can do A and or B or and or C and do it randomly. After 10 years of playing with all variations of these and other combinations, there is nothing that works in all cases. And when it's going to say, I would like to play a song now, don't forget to ignore long songs. If I just want something that randomly plays a few songs in the morning, I don't want to have to listen to the 10 or 12-minute version of Meatloaf's I Would Do Anything for Love. I want it to ignore the adagio. For those who are fans of the 18th century symphony form, the adagio is the boring slow bit in the middle. I don't want to hear that. I want to ignore all my comedy and spoken word records that I've ripped off for discs and put onto the drive, because that's really not applicable. And Pink Floyd, yeah, I'm going to listen to the album of Pink Floyd. I don't want to listen to Side 2, Track 4 in the middle of songs. And of course, we'll have to randomise it by some extra thing just so it's different, because if you don't, the normal randomness in pretty much any system is awful, and you will find that it picks the same songs over and over and over and over again. Except skip songs that have been played recently, so you need some way of storing recently played songs. Think about how the mood changes. If you've got nice soft music and hard music, if it just goes from one to the other, it's a bit jarring. So you're going to have to code that in somehow. So I ended up adding a block feature. I don't want you to play this song, this is a bit dozy, don't play this one, don't put this in that random rotation. And that's fine, but based on what? If I happen to be, I've got a tablet in pretty much every room in the house which connects to my web page which runs to the house. It's quite literally a home page on my website. So I will click a button on there saying, block this song. How does it know it's me? How does it know that I don't want to listen to that, but if I'm at the house and the other half wants to listen to it, it's allowed to play that song? What about location? I'm quite happy having, you know, Barry White in the bedroom, but really I'm not going to be coding to it. So it's got to consider where it's going to be played and why it's going to be played. Time of day. I had to block my Venetian Snares albums because the computer would decide to wake me up with this noisy, thrashy electronic and guitar stuff which is fine for later on, but it's not what I want at 6 in the morning, thank you computer. Time of year. I'm happy to have a nice little family get-together at Christmas with Krista Berg and Fairy Tale in New York and all that stuff, but I don't want it randomly coming up in the middle of June. It just sounds weird. So the whole time you're having to say, right, actually, this is Christmassy type song, this is not playing it in the morning type song, this is only play it when the other half's in, and you get so much extra metadata you have to put in, it becomes so difficultly impossible to get it right. The other half. These are just other little bits that will cause problems if you do try building HA systems. The motion sensors which I have around, they don't detect who you are, it just detects the fact that someone's coming up the stairs, therefore turn that light on. Very simple, but it might be that I personally don't want the light on because I know where I'm going, I'm not going to trip over anything. So I can't do that. You can use Bluetooth, and you can use directional Bluetooth and put a couple, and it will work out, oh yeah, it's that device and they're about over there. Again, that has its own problems when you start implementing it. And the ignore list that we saw here has other issues. So, in conclusion, and almost in time, I think there were no rules about what actually works. You have an idea, and project managers do all the time, oh, we need to do this, but until you've implemented it, you have it running in your house for a couple of months. You don't realise whether that idea works or not. And sometimes, especially things like the random playing of music, you don't realise what the problems are until you've had it live for 6 months or more. Because that can be how long it takes to get round to, oh, right, now I get why it's a problem. Everything should be context sensitive. Why am I controlling it? What is it I'm trying to do with the house? Why is it trying to automate this? But that's only the first step. All these other processes, who is it? Why are they doing this? Still need to get featured in there. And the configuration calibration. The home is such a personal thing. We all live somewhere and we all have different lives that really don't match. Okay, all geeks in the room like to express their individuality by wearing black. But, not looking at you. There is a nice scale, which means at one end of the scale, you want to be able to configure everything, because everyone's life is so personal and so unique. You want to control everything. What sort of time am I likely to get back? How often am I going to do these sort of things? That's very personal to me. The configuration required to get that right and get that running will take you months and months and months. But it will be exactly suited to you. At the other end of the scale, you have 2 push buttons that say run house, stop house. And that's it. And it gets it right some of the time, but not all of the time. And for those that are here for the last one, this is heading to the uncanny valley. The computer is doing something that it thinks might be right, but actually turns out to be really stupid, which makes it even worse. The problem is to get it up to this end of the spectrum, where the decision-making is really smart, is very accurate, means a lot of time, and it's not something Joe Public is ever going to manage to do. Even things like if that then whatever it was that IBM built. It's a fine system, but even though as programmers we think, oh, it's only an if statement, that's easy, most people living in houses would not be able to do an if statement and get it right. Simple cases like, if it's raining, set the alarm for 6 o'clock so I can go for a run. If it isn't raining, then let me sleep for another half hour and wake me up. That's a very simple case. However, you can get that wrong as well. Because you can say, if at 6 o'clock it's raining, don't set the alarm. If at 7 o'clock it's not raining, don't set the alarm. And if it changes rain from 6 to 7, then you have another problem. Because there will always be another problem. I may even have time for questions, I'm not sure. You can read, not the bits I've done here, but about how I've built the home automation system in the books. Don't bother buying them, I get so little royalties now it's not worth it. Buy me a pint instead, that's the equivalent of someone buying 3 books, and I probably talk for longer. So, which may or may not be a good thing. There's some links on the site to stuff, the home automation software you can go and download, so you'll see some of the solutions I've tried to get right. But that's pretty much roughly it, so if there are questions I can probably take them.
Just about.
Just about, okay.
So in your house, is it necessary that everybody has an embedded Bluetooth chip, or at least a barcode for
Yes, as you come through the front door, a great big robot punches you in the face and the chip goes.
It seems like you're trying to solve all the problems in the software of the system that should figure everything out, but it seems like there is a solution that is coming more and more, and that's tools like if this, then that service, and you hand it off to the user, right? Then they kind of program it themselves how they want it. And what do you think about those two approaches? Is it better, should the machine do it all, or should we should make tools to make it easier for the human to do it?
I'm with the idea that it should be as easy as possible for the human to do it. But my belief is that most humans, geeks accepted, they're not going to be that good at the thinking and the logic of even simple conditionals. Because there are cases where it's very easy to make a mistake and you won't realise that you've made a mistake. So I would like humans to be able to do it. But realistically speaking, I'm wondering how we could make it easy enough to get it right and hard for them to get it wrong.
Sorry, that's questions in the pub, please.
Okay.